thing that I've seen is I've seen people do this. What do y'all think about that?
No, that's wrong.
Okay, so what is it supposed to be if it's not supposed to be that? Okay, we're supposed to do the log of the base on the bottom. The base is always going to be on the bottom. In this case, the base is 5. So we got to put that on the bottom. What is this approximately equal to? Negative 1.43. So we can get answers for these that are negative. We just can't put negative numbers into those parentheses where the 1/10 is. That doesn't work. Okay, so for the last one, here's another thing I've seen people do. Log of 7.5 divided by 2.9.
That's right. That's right.
So close, but it's not right. You're right, Naya. We need a log in the bottom. Okay, so there is a big difference between having the log in the bottom and not having the log in the bottom. Okay, good. So on a multiple choice test, though, if I asked you to tell me which of the ones was correct, and there was one without a log and there was one with a log, you got to be paying attention to those little teeny things. They do make a difference. So this is approximately equal to... Oh, we got some different answers. I got 1.89 also. I need to make my pen thinner here. Okay, so make sure you're closing up your parentheses because that'll make a difference also. Okay, so let's go back to the beginning, back to number 1. I know it seems weird that we did that, but I really think it will help you. So going back to the beginning, to this. We've got some similar steps to the ones we saw on Tuesday. In these problems, it says isolate the exponential function. So you want there to only be a base with its exponent on one side. And by base with its exponent, I mean just what I see here. That's a base with an exponent. That's it. In number 2, I see a base and its exponent, but it's multiplied times 2. So we're going to have to get rid of that times 2 first. Number 2 says take the natural log of both sides. Number 3 says solve for x. So let's go back and look at number 1. In number 1, we've already got the exponent isolated. I'm going to change this into a logarithmic equation. Now, this has a base of e. What other thing have we learned about that also has a base of e? A natural log. So I can write this as the natural log of what? What number would come next if I started with natural log? 8. Good job. The natural log of 8 is equal to 2x. Remember, logs are always equal to the exponents. So we know that 2x has to be on the other side of the equal sign. So the 8's going to be beside the natural log. Now, y'all have a button on your calculator that will find what the natural log of 8 is for you. So we're going to be using that. And once we find that, we're going to divide it by 2. Now, one thing I want you to notice, the natural log of 8 divided by 2 is not the same thing as the natural log of 4. You've got to do this part first, close up your parentheses after the 8, and then press divide by 2. So, your x is going to have to be an approximate answer. We can't get an exact answer for this. Okay. How do we plug that in? You're going to press the natural log button. You know where that is? It's under log, yep, by the 4. Press the natural log button, type an 8 in the parentheses, and close the parentheses. Then you're going to type divided by 2. And I got something a little bit bigger than the number 1. 1.04 if we're rounding to 2 decimal places, which is what we'll be doing. All right, Victoria?
So when do you, what's the difference between the L button and the E button?
The E button is what we used for the homework that we did the other day. Mm-hmm. The E button is what we use if we know what the exponent is already. In this problem, we know that the exponent has a 2 and an x, but we don't know what x is. So we can't use the E button. In order to solve this equation, we got to get the x out of the exponent. And we do that with logs. Yep?
What would the calculator do if you used the E button?
What would the calculator do? it would give you the wrong answer for this one. Because when we're solving this, we see that we have to do the natural log of 8. If you use e instead of the natural log of 8, you're going to get a very big number that is very far away from 1.04. Also, if you check this answer, 1.04, by plugging it back into the original equation, you're going to get an 8. If you don't use the natural log button, you will not get the right answer. So you'll know you're wrong. So that's the benefit of checking your work. You always know when you made a mistake. Okay. In the next problem, we talked about this a little bit already. We have more than just a base with its exponent here. We got to divide by 2 before we do our natural log stuff. So what's 8 divided by 2? 4. So I have e raised to the x power is equal to 4. All right, so now I just need to figure out what x is. And it's hard for me to guess at what that is. That's not an easy thing for me to do. So instead of doing that, I'm going to let my calculator do the hard work. I'm going to change this into a logarithm, though. So the logarithm for this would be, what has a base of e again? Natural log. Now you can write the little e down there if you want to. That's fine. But your calculator knows that's there already, so you don't have to tell it. What's the next number I'm going to write down? 4. The natural log of 4 is equal to x, because logs are always equal to exponents. So now I can use my calculator, and again, the calculator knows about this e. You don't have to tell it. All you have to do is enter the natural log of 4 and see what you get. All right, so we got it. Rounded it to 2 decimal places, and we are done. Brianna.
And after you divide, you just do just the end, the natural log equals 4 and 4 equals x. You have to write the x.
Do I have to write this? Oh, so could I get rid of this and just write the 1.39?
No, like the first one. The e, I think you should write it as in 4 equals x.
Yeah. Yeah, you could do that. Just write it as natural log of 4 equals x. Yeah, absolutely. All right, move at your own pace. We may be going a little bit slower than you want to go. Number 3, what's going to be the first step? Divide it by 2. This one looks a lot like number 2, in fact. So maybe too easy for me to go over with you again. I get e to the x equals 2. So we're not going to get the same answer as last time. We're going to use the same type procedure, right? So what's going to be written down next? Good. So we change this to the natural log of 2, which has a base of e, and the exponent is x. So equals x. We grab our calculator, and we let it do the hard work. What's the natural log of 2?
0.69.
0.69 approximately. Okay, so that was too easy. Number 4, though, looks a little bit more tricky. Good. In the first step, it does look like we should divide by 5, doesn't it? But what's the base of this exponent? In the other problems, it's always been e. Do y'all see an e this time? So what's going to be the base of this guy? The exponent is x plus 1. What's the number that's being raised to the x plus 1 power? So the base is actually 5. So when I change this into a logarithm, I can't use natural log, because natural log has a base of e. This one has a base of 5. So I'm going to have to write this the other way, like you guys did on your quiz. The base is 5. What comes after we write the 5? 25 is next, and that's all equal to x plus 1. All right, now, the log base 5 of 25. That's something that you guys learned how to do, and you did it on your quiz. But we also just learned a way how to do this in my calculator. So you can choose either way. Remember, if I'm evaluating the log base 5 of 25, I'm asking myself, 5 raised to the what power equals 25? 2. So all of this is equal to 2. Now you could also put that in your calculator, log of 25 divided by log of 5. I'll write that up here. Log of 25 divided by log of 5, but you'll just get a 2 when you put that in your calculator. So either way you want to do that, we're going to get a 2 for the next blank equals x plus 1. So 1 equals x, yep. X is exactly 1. No need for a squiggle equal sign at all, because I didn't round that one bit. Catch up. Question, Victoria?
How did you know it was going to be 2?
Because, remember, logs are equal to exponents, right?
Mm-hmm.
So I said 5 to what exponent equals 25? And that exponent is 2. So this log is equal to 2. Sabria? Okay, hold on a second. As soon as I get everybody started on number 5, I'll put this down. Okay, in number 5, what's the base that's under an exponent here?
2.
A 2 is. We want this 2 with its exponent to be the only thing on one side of the equation. So what has to happen for that to be the only thing on this side? Subtract 5. So I want everybody to subtract 5 from both sides and then change it into a logarithm with the appropriate base. If the base is e, you're going to use a natural log. All right, Sabria, the pass is ready. All right, so we subtracted 5. We got 2 raised to the x plus 6 is equal to what now? 2 raised to the x plus 6 is equal to 4. All right? Now, what's going to be the base of my logarithm? The base of the log equals the base of the exponent. So the base is going to be 2. So I'm going to have log with a base of 2. What comes next? Eyes open. 4 equals what? X plus 6. Good job. Good. 2, this over here, you can do it in your calculator. Log of 4 divided by log of 2, but you can also think to yourself, what exponent does a 2 need to get a 4? 2 squared. So I get 2 equals x plus 6, and so x is going to equal -4. All right? X equals -4. Now, on our last night's homework, we threw that answer out because it wouldn't work. Can you use negative numbers in exponents, though?
Wait, yes.
That's allowed. You can do that. You just can't use negative numbers in logarithms. Because if I do -4 plus 6, what do I get in that exponent? -4 plus 6 is 2. What's 2 squared? 2 squared is 4, and what's 5 plus 4? It works. Not extraneous. All right, number 6. What do we think we need to do first in number 6? Add the 5. Good job. Let's do that. Add the 5. When I add 5, I get 4x equals 8. Then what? Change it to a log. What's going to be the base of this log? Base of 4. Base of the log is the same as the base of the exponent. So base of 4, what's after that? 8 equals x. All right, what's your question, Charles?
Never mind, because I was about to say
sure?
we had to divide by 4, but then you wrote it in logs, and I was like, no.
Yeah, so we can't divide by a base because it's not multiplication that's happening there. Okay, so this one's a little bit more tricky to figure out. If we change this to an exponential, we'd have to figure out an exponent on a 4 that gave us an 8, and that doesn't really work. So let's use our calculator. Log of 8 divided by log of 4. 1.5? Awesome. We didn't even have to round that. It's exactly 1.5, so I don't need the squiggle equal sign. Awesome. Okay, so on to the next group. Starting with number 7. We've done some like this already. See what you can do with number 7, 8, 9, you should be able to get through the rest of these without too much help. I'm going to walk around with the answer key for a few minutes and see how you guys are doing, and then I'll come back up here and work on some. Number 7, you should have a positive 1.61. Number 8 is 0.53. Number 9 is just 0. Number 10 is 1.30. Number 11 is negative 2.82. And number 12 is negative 6. So you have the answers, but more importantly, like I said, we need to make sure we know how to get them. So if you don't have one of these answers, let's talk about it. Which one were you saying, Mason? Number 12, sure. Let's start with number 12. In number 12, first step, we got to get the exponent alone with its base. So we need this to be the only thing on one side of the equation. We got to get rid of that negative sign too, but that's not the first thing to go. How do we get rid of the 7? Subtract it. So we're going to have a negative 2 raised to the x plus 7 equals a negative 2. How do I get rid of a negative in front of a 2? Divide by negative 1 or multiply by negative 1. Either way, you're going to get rid of that negative. So divide by negative 1 here, and I get positive 2 raised to the x plus 7 equals positive 2. Now, if you tried to do this without getting rid of the negative first, if you've already done that, you'll see it doesn't work out very well. Because remember, we can't take logs of negative numbers, and that's what you would have if you didn't get rid of that negative first. So now that I've done that, I'm going to rewrite this as a log. What will be the base of my log? Base of 2, and what comes after the base? Another 2 is equal to the exponent x plus 7. Yeah, so 2 raised to what exponent equals 2? I can put that in my calculator, but basically I'm doing log of 2 divided by log of 2, which is just 1. So you should have 1 equals x plus 7, and so x is going to be negative 6. Lexi?
Can you go over number 11?
Everybody good on 12 before we switch? Awesome. If you're good on number 12 and you've got all the other answers, check out page 16. That's your homework for tonight. All right, number 11. What do you think we should do first, Lexi?
Well, I added the 1 to the
Good. That's the first thing we need to do. Add the 1 to the other side so we get a 9, right?
Yeah.
Okay. After that, we can't do anything until we get the x out of the exponent, and to get the x out of the exponent, we need a log. So what would be the base of your log here, Lexi?
5.
5. The base of the exponent is the base of the log. And the exponent is what the log is equal to, so that means that we're going to have a 9 right next to the 5. Okay? Now, to evaluate this in my calculator, I'm going to have to do the log of 9 divided by the log of 5.
Oh, I see what I did.
And then I'll subtract the 9 and divide by 2.
Wait. Why is it 2x plus?
Okay, what?
Why is it 2x plus 9?
It's supposed to be 2x.
It's supposed to be 7.
Yeah, sorry. Okay, so this should be a 7. Oh, wait. No, it's because I added 1 to both sides there. Oh, you're talking about here? Okay. All right. Wow. We okay? All right. Okay, so we put this in our calculator. And then after we put that in our calculator and press enter, we're going to subtract 7. And then after we subtract 7 and press enter, we're going to divide by 2. So just press enter after every step. Otherwise, your calculator may not be too sure about what you're talking about. Colin, you had a question?
No, I'm good.
Okay. Any other questions on the 4 we haven't worked out? Bailey?
Number 8.
Number 8. What's the first thing we do in number 8, Bailey?
I think you need to isolate them.
Good.
Didn't know what to do with the 12.
Yeah, so how can we get rid of that 12? Divide. It's multiplied, so we're going to divide to get rid of it. We're going to get a fraction. That doesn't mean we're wrong. It just means we got a fraction. Or a decimal. 0.6 repeating could be rewritten as 2/3. If you'd rather not write 0.666666666. Now I need to get the x out of the exponent. The only way to do that is with a log. So what's the base of this log? E. So I can write this as log base E of 2/3 equals 3x minus 2. But what type of log has a base of E? A natural log. So instead of writing log base E, I can just write ln, and then I don't even have to write the E. And I can put natural log of 2/3 straight into my calculator and see what that equals. But that won't be my answer because I still have this minus 2 and this times 3. So then I'll add the 2 and divide by 3 to undo that. Does that get you where you needed to be, Bailey? You good with that?
Yes.
You good? Okay. And Colin, you need to ask the same question. Are you good with that? Okay. Anything else? Kadian? Yeah, I think I erased that when I had a 9 there, and I erased the 9. So yes, it should be a negative. Tyson? Number 10? Yep. Tyson, what would I need to do first in number 10? Isolate the exponent or the power. Here it is right here. So what do I need to do to get it all by itself?
Find the base.
Well, the base is 2, and it's inside that circle. See the minus 2 outside the circle? How do I move the minus 2 so it's no longer on that side? Add it. So I'm going to add 2 to both sides. I'm going to have 2 raised to 3x over here. And what's 13 plus 2? 15. Okay? So now that I've isolated the power, I got to get that x out of the exponent. The only way to do that is with a log. What's going to be the base of my log? 2. So I'm going to have a log with a base of 2. What will come after the 2? 15 goes next, and that is equal to 3x. All right? So all of this I can put in my calculator, and it's going to be the log of 15 divided by the log of the base, which is 2. The log of 2. Instead of just a 2, you got to divide by the log of 2. So log of 15 divided by the log of 2. Make sure you put parentheses after the 15 and after the 2. And then divide by 3. And you should get 1.30. Thanks, Colin. Okay. So that's not the answer, though. We got to divide it by 3 next. Yeah. Did you get it?
Yeah.
Awesome.
And if I finish my homework, do I get extra
Mm-hmm.
points?
Yep. Okay, anybody for 7 or 9? Charles? Okay. Number 9, Charles, what happens first? Minus 2, so I get 4 to the 3x power equals 1, right? What's next? Okay, what will be the base of your log? What's the base of the exponent? Base is on the bottom of the exponent. It's in the bottom of the log. What's on the bottom of this exponent? 4. So that's going to be our base for our log also. What comes after the base in this situation? Nope.
1.
1. There it is. So log base 4 of 1 is equal to the exponent, and the exponent is 3x. Okay, so what would I put in my calculator to evaluate what the log base 4 of 1 is?
Just log 4, I think. Because if it's 4 to the 1, it doesn't really matter.
Well, remember, the 1 is not the exponent, so it's not 4 raised to the first power. It's 4 raised to what power equals 1? Or remember what we did over here? Remember all that? How could I do this problem like that?
Oh, would it be log 4 and log 3, I think? Like divided?
It's going to
4
be
divided.
division, but log of something else. Log of what divided by log of what?
Is it log of 3 divided by log of... No, I'm tripping.
Yeah.
Log of 4 divided by... Am I right with the 4 or no?
Nope, 4 doesn't go on top.
Damn. I mean, the 3 goes on top because it's the bigger. Is it written bigger?
Okay, so we're only looking at this stuff.
Which? Oh, the 1 and the 4. Never mind.
All right, so which
Log of
number goes
1.
up top? Log of 1 on top and
Log of 4.
on the bottom.
Damn.
Okay, so the base always on the bottom. It's on the bottom in the exponent, it's on the bottom in this equation.
Everything except that. Say that again. I'm sorry.
Okay, the base is always in the bottom. It's in the bottom of the exponent here, it's in the bottom of the log here, it's in the bottom of this division here. So base is always on the bottom. So log of 1 divided by log of 4 should give you a 0. And then you just divide 0 by 3. 0 divided by 3 is 0 also. All right.